Hello, this is Ben from Gencovery, and I'm here today to tell you more about Constellab and how you can develop your own bricks and tasks into Constellab. We'll not see how you can develop your agent into Constellab. Please check out the video about this. And this is a technical video made for a technical person comfortable with Python. So if you don't know anything about Constellab, please check out our demo video, and everything you see in this video is available in the Fair Open Access offer from Constellab, so you can do it today for free and try everything I will do today. So I'm connected to Constellab here, and I'm into my data lab page, and I want to connect to the Codelab, which is the dev environment. So to do this, I just have to go to the dashboard and click on this dot and open the Codelab information. So this is a link that explains a bit about Codelab, and you can copy the token here and open the link from there. So I'm already connected, but it will ask you a user and password. So you just say Codelab as a user and the token as a password. So when you arrive there in your Codelab environment. So this is a VS Code online. And in this environment, you are free to use it as you want. You can open some terminal, just run some command, for example. So you can install your own packages, run some command. You can also install other extension if needed. So there's already some basics extension installed in the environment. So when you're here, you're on the lab user folder. You have a brick folder here, which is important. It is the place where we will develop our own brick. And you also have a notebook folder where you can create your own book and run your notebook directly from here. I recommend to upload data in the data folder if you want to test some notebook. And today we'll not see the notebook. It's a subject of another video. We see how we can develop our own brick. So let's get on with it. I open the brick folder into my terminal. Yeah, I want to enable this. And I will just clone our JWS Academy brick. I put a link in the description. Sorry. To have a start. You can also create a new brick with the JWS command. So JWS brick generates this brick, for example, and it will create a skeleton brick for you, so you can start on an empty brick. So for example, yeah, it created this skeleton here with an example of a brick. So I will just remove this. So once you have brick in this folder, it's automatically loaded into the application. So we just see if the brick is correctly loaded. So to do this, we need to start what we call the dev environment. So in each lab, you have a production environment, which is the basic environment you got. So when I'm connected to my data lab here, I'm connected to my production environment, so I see all my data. But you have also a development environment, which is separate from this one, different database, different datas. And you can use this environment to test and develop your own task, your own brick, your own agent, for example. So to start it, you just have to go into the play button and click on Start and Debug the environment. Just be aware that it starts the VS Code debugger, so it might be slower than usual execution. And you can start the environment from the command line to skip the debugger, and it will be as fast as the production environment. So it should take a few seconds, and at the end you should see this message which tells you that the dev environment is ready, and then you can log into the dev environment. So to do this, go back to your lab interface and open the settings, and this button should be enabled, the dev environment. So just click on it, and here you switch on the dev environment. So you can see you are in the, once again, dev environment, because you have this kind of weirdly looking bluish bar on the left. So I'm connected to my environment. Now I can do my test and I can see my brick. So to check if your brick is correctly loaded, you can go to settings and monitoring, and you should have your brick here loaded with the name you have, and it should be in success or warning if there's some warning. So my brick is correctly loaded, and if I create an empty scenario, for example, the test one, I should see my brick here too, And if I filter, I see some tasks in my bricks. So this tells you that it's correctly loaded. Okay, so back to the code. And now we want to develop and create our own tasks. Okay, so to do this, I will follow a tutorial we made in JWS Academy, and I will add a link in the description about it. And we want to create a simple task that apply a factor to a table. So really basic tasks, but can be useful, and you see how it works with that. So I open the tutorial folder here, and the table folder here, table factor folder, sorry, which is ready to be used for our factor. So I will open the terminal here. So just let me copy this first. And then I will run the command to generate my table factor task. So this is JWS or CLI tasks generates, and here say table factor in Pascal case. So this will generate a skeleton of my tasks. Okay, it was not refreshed. Sometimes you have to refresh it. You can do it here. Okay, just a simple bug here. Move it. And this is a skeleton of a task that will help you to develop it. So let me just check my notes right there. Okay, so this is a task. You can see that it's decorated with the task decorator imported from JWS core, and it extends the tasks class. So those two are mandatory to have a task, and there is also a run method here that takes parameters and inputs and generates some outputs. So those are the mandatory information to develop a task. First of all, I need to define my input, output, and configuration of my task. Just before that, we can check if our task is correctly working by just trying to restart the dev environment, and our task should appear in the tasks list. For now, it does nothing, but just to see if it's correctly loaded. Just waiting for it to start. Okay, it started, so I come back in my dev environment. And now, if I filter by JWS Academy, I have here my new table factor tasks. So to make it more clear, I can create a human name here to describe my task, and I can call it table factor demo, for example, so we will see it more clearly. Okay, so it's ready to be used. First of all, I want to define my input. So as this is a table factor, I need a table as input. So first, I need to import the table class from JWS core. So the table is basically a wrapper of data frame, which adds some metadata information with tags, and to manipulate basically table and data frame. You can find information about the table in the technical documentation of community. And in technical documentation, if you search for table right there, you should have the table resource and have all the method it adds, and how you can use it. Okay, so I need to declare that I want the table as input. So I will create a dictionary here with my key, which is an input table, my first input. And this is a specification of an input, so input specs, sorry. And I define the type here, as we can see, resource type. So I set table, and then I can set a human name for this input, which can be more easy to understand. So for example, I can call it input table, and I can set a short description. This is my input table, for example. And you can also set some optional or skippable. So optional made your input optional, so the task can be run even if it's not plugged. And skippable, it's a bit different. The task can be run even if it's plugged but not provided with the input. But for this one, we want the table to be set, so just leave it there, so it's a monetary input. And as an output, I have another table because I just applied a factor. So I create output table right there, which is, an output spec, a type of table. It could be another type. I can add as many input and output with different type with no problem. Is optional. No, I will let it for false because it's mandatory, and I can say human name output table, for example. So with this, I describe my input and output, and now I want to describe my config. So my configuration will be a factor, so a number, which will be applied to the table. So to do this, I create this new key factor, which is an int parameter. So I need to import it from Constellab. So basically it says that this parameter will be an int. We have a lot of parameters like string, boolean, text, some special parameter like code, param set, which is a list of parameters. So there is a lot of parameters linked in the documentation in community. And I will create a human name for this one too, which is my factor. And for example, a short description, factor to apply to table. So with this, I have my input and my config. I can check if it's working by just reloading the dev environment and to try to add my tasks to my playground to see if it has the input and output. So let's just, okay, it started. So I can refresh the search. And now I have my table factor here, which now has a style because it takes the style as for input. I have a description here. So I can click on it and it adds the tasks to my playground. I have my input, which is called input table, and I have my output, the output table. And if I click on it, I have one factor, which is mandatory, as you can see with the tool, and it's a number input, so I can just put a number. So I'm ready to run it, but I have first to code my task and to apply the modification. So to do this, we remove this small code. And let's do it. So first I need to retrieve my input to apply the factor to it. So I can do it with this line. So I use the input parameter here, and I use the same key as I have described in my specification. So this should return my input. And I know it will not be empty because this parameter is not optional. So when I'm here, I know this table is provided. So with this, I can retrieve my table, and then I want to retrieve my factor. So pretty much the same. I can use the param here, parameter, and use the key here. Oh, sorry. Okay, so the same key, and it's not optional, so I know it will be provided. I have a parameter, I'm ready to apply my factor, and I don't want to manipulate a table, for example, because I don't know all those methods that are specific to the JWS core brick. I want to manipulate the data frame directly, so I can get the data frame with a simple line. So I like to type my parameter to have the IDE helps me around. So I just create my data frame and retrieve my data frame from the table. So input table, and I have a method which is called get data. That helps me. Okay, yeah, it finds it. It's a bit slow today. It helps me to retrieve the data frame inside the table. And now that I am a data frame, I can create my output data frame, which will be the result of the factor. So basically my input data frame multiplied by my in factor. And that's it. My data frame is ready to be set as output. But here I want a table as output, but not a data frame. So just to create a new table, I can simply create it with my data frame. So by settings, so df, sorry. And this will be my output table. And now I need to provide my table as output of my tasks. So to do this, I need to return a dictionary with the key equal to the key I define here, and the value, which is my new table. And that's it. To make the update available, I need to rerun my my dev environment. And just be aware that here I will not have to remove it, but sometime if you change the input, output, or spec, you have to remove this block and recreate it later. Okay, it's not ready yet. And to recreate it from the interface, because it will load the new input and configuration. So if this is not what you expected, just create a new one and it should be okay. So this is ready. For example, we can let's create a new one. So I retake my table factor here. Oh, this is this one, sorry. Oh yeah, this is my, yeah, I showed the wrong one before, but this is my input table here. And I can plug my inputs. So let me check if I have, yeah, for example, well, it's not real. Let's take this table. Now, you know what? We'll import a table. So to do this, I can import a table from the iris dataset. I have a link from GitHub that I can show it to you. That allows you to get the CSV file. And once it's a CSV file, I can import it as a table, convert it from file to a table, to have a table to be able to manipulate it. So here I have a table. You can see the type here, table. And if you manipulate the table here, you can see the documentation too, with all the method and how you can manipulate it. So back to my scenario, which is hidden here. And here I can, yeah, I wanted to plug the new table, that's it. So I'm taking the iris 4 here, and I apply a factor of 10, for example. And, oh, sorry, I forget to save. And then I can run my process directly from here. So I have a table here with some numbers, and here I should have the same table with the factor if everything goes as planned. So it takes a few seconds as I have a lot of bricks to load. Okay. And yeah, it works. So it also worked for the string, but now you have 51 instead of 5.1 and 35 or 3.5. So good. This is how you can create a simple tasks in Constellab. And now we see how we can debug it to see if there is a problem, how to understand the problem. So there might be different problem, but let's just, for example, you can, to debug, you can use the log information. So in each task, you have all those method available to log some messages. So for example, here I can say, just say my factor is factor, just up, and this should log a message into my tasks. And I will also show you how you can debug, because as we are plugged in the dev environment, everything you run from the interface here is running the code you have here. So you can directly debug the code here, and this is why when you update the code, it updates the thing running the interface. So it's started. I can now reset my scenario and rerun it. And this time, as I put some breakpoints into VS Code, I will be able to stop there and debug my task if I have any problem. It can be really useful if you are used to the debug information, the breakpoint, to go step by step and see what's wrong if you have a problem. Okay, I see what's the problem. Let me just deactivate this initialization of the week. Okay, so here I'm stopped into my scenario. So my scenario should be, if I just refresh, running, because it's currently running. And from there I can see all my parameters. So with those buttons I can start, stop, continue, basics, debugging information. For example, I can check my factor value. I can modify it if I want. So let's say factor regard 20 for this time. I can check my table, and I want to, access my data frame, for example. Everything you got here. And you can go step by step and see. So I just continue the run. And here we should have this message logged, and also the factor is 20 as I modified it. So if we come back here, I have a factor of 20 because this is not 51 anymore. And if I open my task, in detail and messages, I see all the messages I logged into the task. So this can be useful to debug. You also see how many time it took. So it took 48, it took a long time because I have the breakpoint. You can download the messages, and you can also open the server logs from this time, from this part, to see everything that happened on the server during the execution. And then you also have the monitoring section, which shows you the consumption of your CPU, RAM. So we have a problem of color, but anyway, during your task. So if you have a task that is using a lot of RAM, here you can follow the usage of it only during the period of your task. So this is useful to debug and understand what is happening on your data lab and how your data lab react to your task if it's used a lot of resources. Okay, so this is how you can debug it. And just a last thing that can happen if, for example, you made a mistake in, I don't know, the Python import here. You have a mistake in your code, you should see some error and warning into the log, and your brick will not be available anymore, but the lab should still start. So here you have a lot of errors. So get used to check the logs when you're starting your dev environment to see if anything is going well. And for example, in this case, the Brick Academy is not, this task is not available anymore. So sometimes you will have all the brick that is broken, sometimes only the tasks. And if you don't find the brick or don't find the tasks, just go in the monitoring section and you will see here some messages that explain what is happening. And so this tells you that there is a problem, and here you can, in the logs, find more information about the problem. Okay, so that's it about a simple tasks. So now what can we do? Because this is Python and we can do a lot more in Python. So basically you can do anything that is doable in Python. You can do it in a task. You can connect to external DB, connect to equipment, get some external source, transform data, generate data, anything you can do in Python. And the good thing is that you can also list all the packages that are installed by default into Constellab. So there are a lot of them, like for example, NumPy, Pandas for data frame, Streamlit to run some dashboard, and a lot of other things. You can use those packages directly, but you also can install your own package in the data lab or use virtual environment. So to do this, I will just show you an example of a task we already done. So in solution in Blast, you will see an example of how we can run a Blast, which is I can't explain it, I don't really know how this works, but basically to do this, we needed to use an external package and run a command line to run the Blast. So it's doable in Constellab, and this is how you do it. So this is the tasks, once again, tag with the annotated with the tasks that extend tasks. And here I have all my run method. The first thing is to download the result from the database, for example. So I use this class. And then I create a shell proxy. So proxy and shell proxy and environment shell proxy are classes in Constellab that you can use. Here you have some information about it. That you can use to run some command line and run some command line in a virtual environment. So this is how it's works. I'm just creating here a conda shell proxy, which is from this method. And it creates a conda shell proxy using this blast conda file here. So this proxy will use a virtual environment defined by conda here with the blast and biopython packages. And with this, so in this shell proxy, I have access to, with this I can run some command line into this virtual environment. So just after, when I just run gnzip-c, it's running these tasks in the virtual environment. And after that, I use the make-blast-db, which is available from this package. And I can access it because this shell proxy has access to the virtual environment. And that's it. We can use virtual environment. So in the same task, you can use 1, 2, 3 virtual environment. You can share configuration of environment between different tasks, and it will use the same environment and not reinstall it. And once you run your lab, so I will just run it, you can see all the installed virtual environment into the application. And you also, if you open the logs, the message, you will see information about the installation of the virtual environment. So if I come back here, I have some scenario that was running, for example, here, Blast demo, which use my tasks. So here I can check up my documentation of my tasks, and it's using the GWS.soBlast. So if I come back here, this is my tasks, so Blast. And so this one is using the virtual environment. So I have a lot of messages here, but here I see that the virtual environment name, this one, is already installed, so it skipped the installation. And then it ran the command line here, make blast, for example, into the virtual environment. And with this, you have a result of the blast made into Constellab. And in the monitoring, you have here a section where you can navigate through your virtual environment and see when it was created. You can delete it to force the recreation later. So with the shell proxy, you can run command line outside virtual environment and inside the main environment, but you can also run command inside the virtual environment, and Constellab takes care of the installation, the usage, and everything about the virtual environment, so you can do it easy. For now, we support Conda, Mamba, and pip virtual environment. Okay. So you've created your tasks, you're ready to basically to use them and to deploy it. So once you've made them available into the development environment, you want to share them with your team or share them with everyone, or just keep it for you, but deploy it. But first of all, what you can do is create some tests. So in here you have a test folder in each brick, and you can create some, not this one, some tests from there. We choose the standard Python test. And with the task runner, you can run your tasks to see how it acts and to test it. So for example, this test uses the data frame, create a table, call the table factor, table factor task, which is here, already used, and apply a factor of 2 and check if the result is 2. So I can test if it's working. So to test my test, to run my test, I have two options. I can use once again this panel and select the test and debug a single file. So I run it, and then I have to run the name of all the test file I want. So this file is test, so table factor, and then the name of my brick. And this should run my test, and if I code my task correctly, my new task, it should give a success. Okay, I have a small problem. So it can't import the tasks. Let me check if I put it in the correct place. Debug scheme tutorials, table factor. Oh yeah. It's one more. Yeah, there was a warning. Okay, so I can run it again. Let's save the configuration. And you can also run the test with a command line, which can be easier, but you don't have access to the debugger, because if you run it this way, you can debug it. For example, here I'm debugging it, and I can run it. Okay, so my test was successful, and I can run it in my command line. So the easiest way to do it is to enter the command line into my brick, and then I can use the command line GWS server tests and put my name of my file. As I am in my brick folder, it will automatically detect the GWS Academy brick, and it should run the correct test. If I'm outside, I have to set the name of my brick. So yeah, it was a success. So that's it, how you can test your tasks to make it more robust, and to, for example, when you create a new version, to see if everything is working correctly. So now my task is developed, it is tested and ready to be shipped in production. So to do this, you can do it in Constellab. It will simplify you the way of sharing, deploying, and maintaining your tasks, your brick, and your library. So to do this, we have let me just check the link. We have a documentation on technical here, documentation, and developer guide here, development environment, and brick, and deploy your brick version. So first of all, there is a checklist of what you have to check before deploying your version, like running tests, declaring the version. And we'll do it, I will show you how you can do it. So first of all, you just have to open the settings. Oh yeah, I forgot just one thing. Another thing about installing package. Here, if you want, you can, in the settings.json, the main settings of a brick, you can install custom packages from here. And those packages will be installed when the brick is installed in the lab. So it will be made available in the main environment without using virtual environment. Just be aware that if there is a lot of bricks and a lot of packages installed, there might be some conflict between them. So virtual environment is a more robust way of installing packages. And you just have to save the name of the packages and the version of it. Sorry. So for example, 1.10.0. Okay. So I have my packages, everything is ready, and I want to declare a new version. So I come to the settings. I set my new version. as this is a brick, it needs to be commit and push. So I have to push my new modification, my new version right there, for example. So you can use custom repository, private or public repository. Both are available. Once you pushed, you have to create a tag. So for example, this one, and you can do it with the interface or do it in command line. This is explained in the documentation. Create a tag that is the same value as the value in the setting. So if I have 7.0, I need to create the tag 7.0 and I need to push my tag. This is how the system will retrieve the correct version of your brick. And once it's ready, you have to download the settings.json file. You can do it from the VS Code here, and then connect to Constellab, the Constellab community. Either this is a new brick, so you can use the new brick button and import the settings.json file, for example. So yeah, it already exists. Or you can, if it's a new version, so for example, this is a new version of the Academy brick, you go into your brick, you need to be author of the brick, go into version, and here you can upload a new version. And you can check when you upload that all the values are correct here. You can check the version and the reference. And once you save it, I will not do it to ever declaring a new version. It should be available in your lab configuration. So once it's saved here, you go back to your lab configuration right there. And here you can update your brick. So this was Academy, which is not available here, but you can add or update the brick. Select the one you want and select the version. So here I add a new brick if it's a new, but if it's a new version, I can use it from here. And just after that, you restart your lab and yeah, all your new tasks or your correction will be available. So this is how Constellab simplify you the deployment of your package, your tools to make them available for other teams. And as I say, if it's a private brick, when you create your brick, you can reference here some token for accessing the brick. You can generate them in GitHub or GitLab, some specific token to allow the system to download your code and put it in the lab. Okay, let me just check my notes. Yeah, that's it. This is how you can develop a brick and some tasks into Constellab. This is how you can debug it, test them, and deploy them easy. So the good thing is that you can do it. You can do all of those steps into Constellab, into the Constellab environment. And the good thing is that you're developing your task in Constellab in the dev environment, which is the same environment as the production one. You have the same packages, the same version of Linux and everything. So this will reduce a lot of bugs you can have because you are developing in the same environment as the production one. So everything should work the same. And if you follow the rules of creating tasks, creating inputs, configuration, and everything, you will have access to all the traceability of Constellab, all the compatibility with other bricks of Constellab, and everything. And once again, Constellab helps you to deploy new version and simplify the way you can deploy new version for your teams. And after deploying it, also simplifies you how you can maintain it into Constellab, and how you can debug it with all the tools of monitoring, messages, and logs, and everything. Okay, and once again, this is all available in the fair open access offer or any offer in Constellab. So feel free to test it and give us some feedbacks. I just remind you that we have a Discord here available, so you can log into Discord and exchange with other members about development into Constellab if needed. And I will link to you some video about how you can use this development skill to create some automatic notes once your pipeline is run, and how you can also develop your own dashboard with Steamread, for example, and how you can create some interactive dashboard that manipulates a lot of things and generate results. Okay, I think I'm done, and feel free to have some question in the comments, and hope you'll test it and have a good day and happy coding. Bye.